All right, first announcement. The high grade on this quest was a 99. The median was an 86. What does median mean? Middle after we do what? After, is it adding them? Is that what we do to find the median? Morgan? Yeah, there's one way to find average, and that's to add all the grades and divide by however many people took the test. But that's not this word. Victor? That's true, but you're saying in the middle. So don't we have to do something first before we know who's in the middle? Right, we line everybody up numerically from the high grade to the low grade. Of course, we would never do this in public, but if we imagine lining everybody up from high grade to low grade, the middle person was sitting at an 86. So I'm just giving you information. I'm not making a judgment. We each have our own standards for like what constitutes a good grade and what's not so good. But I'm just telling you that that if you scored above 86, then you were above the middle, and if you scored below 86, you were below the middle. Let's take a look at the calendar. And I will say that we have our first exam coming up, and it is at the moment scheduled for March the 12th. So there's a little bit of time, but it will be here before we know it. It's roughly 2 weeks from now. In fact, when is it? March 12th. Is that a Wednesday? Maybe a week from this coming Wednesday. So there's some time before the first test, but not a whole heck of a lot of time before the first test. And the first test is worth more than either of the quizzes that we just took. So if you're not happy with your performance on either of the first quests, there's an opportunity to really boost your grade by doing well on this first test. So between now and then, here's the plan. Today we're going to talk about solving systems of equations graphically. Next class, we're going to talk about solving systems algebraically, and then we have 2 days on applications, word problems, all related to systems. So what word is the same in all of those? Systems. So apparently the next 4 classes we're going to spend on this idea of systems of equations. So that's our next big topic. Before we do, just a couple of quick announcements, and again, we're going to start on page 63, so go ahead and open to that page. Okay, one announcement is over here on the whiteboard. I actually don't even know whether what I'm saying is true or false, but I'm just going to give you this information. GCC's email system is through Gmail, and I got an email a couple of days ago from our IT director here that said that it used to be that you would log in with your last name and your first initial and then the first 4 digits of your student ID number, but that Gmail made some change without giving us really any advance notice, and that now your username is that whole thing, but with this additional suffix here at the end, the @studentemail.gcc.mass.edu. And I know that that GCC was trying to contact and work with Gmail to fix it so that we go back to the short version of the username. But just putting it out there that if all of a sudden you're not able to log into your GCC email, try sticking this appendix at the end, all right? It may have already been resolved, I'm not sure, but just wanted to give you that information. Next piece of information could be one that's very lucrative to some of you. If you go to the GCC main page, right down here on the right is this thing that says scholarships in capital letters. So there is a collection, a big pot of money that is available and distributed to GCC students every year in the spring semester. It's called the GCC Foundation Scholarships, and there's a whole long list of them. And let's click on this guy right here. So here's no, let's go to this one here. So here's a list of the scholarships. We're not going to look at all of them, but just a smattering. There is a 25th anniversary scholarship. There's one of them. It's worth $800. Students, full-time and part-time, are eligible. Awards are made on the basis of scholarship, financial need, and character. Some GCC student is going to win $800 in the next month or so. And then we can scroll down a little bit, the Brattleboro Nursing Scholarship. Some of these scholarships are really specific to a major or to a characteristic or something like that. So I'm guessing if you're not a nursing student, you're not eligible for that. But I can guarantee you that everybody in this room is eligible for many of the scholarships that are in this document. It's a pretty long list. And if you look at these dollar figures here, I mean, this is a lot of money that's going to be given out. There's 2 $1,100 awards to people transferring to 4-year colleges and demonstrate financial need. $3,065 awards. So lots and lots of money is being given out. So here's the deal. Like I said, somebody is going to win each of these scholarships here. There are roughly 2,500 students at GCC. I don't know how many of them are going to apply to these scholarships, but I'm guessing very, very few. So in terms of probabilities, this is your best chance at getting any kind of, like, sometimes people play the lottery, right? And your chances of winning are like nothing. They're just like a hair over nothing. But your chances of winning here are so much greater because it's only 2,500 GCC students eligible. This isn't all Massachusetts or all US. It is only students currently at GCC, most of whom have no idea this is happening. The way to apply, it's actually pretty painless. Is there anybody that has applied like last year or this year? Yeah? Can you give us a sense, how long did it take, the application process? Megan? Mm-hmm. Mm-hmm. Letter of recommendation. Mm-hmm. Morgan and Lauren, how were your experiences? Time consuming? Mm-hmm. Yeah, and so it says here there's one common application. That's a very good thing for you guys. It means you don't have to apply separately to each of the 10 different things you're interested in. One common application, it's a fairly painless process. Most of it is just basic information about you. All scholarships require something between 250 and 500 words. You just write it one time. Take a little bit of time to write about yourself. And then some specific awards have other things that they require as well. But generally speaking, most of these awards, it's just fill out your basic personal info, like stuff you see here at the bottom of this page. Write one essay one time, submit it. At some point you click on, I'm not going to get there, but if you go through the process here, at some point you click a bunch of check boxes that say, I want to apply to this one, and this one, and this one, this one, submit, and you're done. And then you just wait. And again, this is a much greater chance of you winning some money than any lottery or raffle or 50-50, any of that stuff that you might spend $1 on here and there, okay? Now, the deadline for applications is coming soon. I think I saw the date. It's right around the corner. March the 2nd is the deadline. Is that Monday? Sunday. So, I'm not giving you a lot of time to think about this. But like I said, I think you have better odds now than you may ever have in your life in terms of just winning money. Any questions? March 2nd, Sunday. Okay, good luck. All right, let's jump into page 63 here. And we're going to skip around a little bit in this section. I think I just wrote way too much stuff here. So here's the basic idea. Let's take a look at this table. We're going to rent a car, and we have two different companies that we could rent from. So company A is going to charge us 30 cents for every mile that we drive this rental car, and there's no fixed charge per day. So it's just a flat 30 cents per mile. But then the other option is company B. They're going to charge only 10 cents a mile, but there's also a fixed charge of $20 per day, regardless of how much or how little you drive the car. Can you spend the next 30 seconds and discuss with your neighbors which company is the better deal for you? There. Company A or B? Ryan, which one's better?
We found that if you're just doing a short distance, I think it's better because I spend that $20 actually.
Hmm?
But if you're gonna go a long distance, like hours and hours during the day.
Okay, so Ryan says if you're going a short distance, A is better, but if you're going a long distance, B is better. Other thoughts? Agree? Disagree? Yeah, it seems reasonable for exactly the reasons that Ryan provided there, right? Like you got no fixed cost in the beginning. So if you're not going to drive very far, then ponying up 20 bucks just for getting in the car is going to take you a while to make up for that, even at this cheaper mile rate. So if you agree that it's cheaper to go with A when you don't drive very much, and it's cheaper to go with B if you drive for hours and hours, as Ryan says, then would you also agree that there's probably some magical number of miles we can drive where what happens? Where it's equal, where it's going to be the same charge to you regardless of whether you choose A or B. And so what we're after here is to figure out where that magical cutoff is so that we can make an informed choice as a consumer. Like let's say the answer is 250 miles is the cutoff. And if you go less than 250 miles, then company A is better. And if you're more than 250, B is better. And if you go exactly 250, it makes no difference. You'll pay the same for both. And then we can make the choice based on whether we think we're going to drive more or less than 250 miles. So that's what we're after here. So let's come down here and start filling in some blanks. We're going to write down a formula here for the cost as a function, sorry, we don't know the word function, a cost in terms of the number of miles that we drive. So let's just highlight some words here. The daily cost Y, so Y represents the cost, and X represents the number of miles that we drive, okay? Those are our two variables. So let's fill in. What is the cost for renting with A? It's going to have X in it. 0.3 up at 0.30X. You guys agree? That captures 30 cents per mile. Okay. How about company B? That's 0.10X. And then the plus 20. Can we buy that? So 10 cents per mile plus the additional $20. Well, all right, I feel bad about company A now. There should be, I mean, it doesn't look the same. What's the number that could be out there? Plus 0. So of course you don't need to write it, but just so that we see they're exactly the same pattern. And so these two equations right here are called a system of linear equations. So a system just means more than one equation. That's all. So there's some vocabulary we're going to skip past. And what we're going to do is we're going to graph these two equations right here. We can ignore the A and the B. We're just going to graph y equals 0.3x, and we're going to graph y equals 0.10x plus 20. And we're going to do that by plotting a couple of points. This was some overkill. I don't know why I needed so many points in here. We just need 2 points, right, to plot a line. So can I ask folks to just fill in the first row and the last row for both tables? So I'll write the formula up here again. So this one was 0.30x. And this was 0.1x plus 20. So if we plug 0 into the first equation, what do we get for y? Also 0. So that's the 0.00. And if we plug 140 in for x, 42 is right. So that's 140 comma 42. Any questions on how we get either of those numbers? So then fill in the numbers in the other table, and then you're plotting 4 points and drawing 2 lines. Take a minute to do that. Use a straight edge when you get to the part where you get to draw the line. Okay, so we fill in our tables and we get 2 points, well, 4 points. And then we're going to plot those 4 points. And we're going to draw 2 lines. So I'll first, and again, it's important to use a straight edge here because the graph is, like having an accurate graph completely decides whether or not you're going to solve the problem correctly. So try to use a straight edge if you can. So there's my first line. And there's my second line there. Did you connect? I think you connected the wrong pairs. Oh, this guy's in the wrong spot. That should be up here. 0, 20. Yeah, everything else is good. Throw it there and then connect again. Yeah, just any two. I did the first and the last ones, but really any two is fine. Yeah. Okay, so let's come back together. I think just about everybody's got our 2 lines drawn in there. Just looking at the table, forget the picture. Which one is cheaper if you don't drive at all? Remember, it was the Y values that tell you the money. So A was cheaper, right? Because if you don't drive anything, you pay nothing for A, but you pay $20 for B. So that's there and there. What if you drive 140 miles? Which one is cheaper? B is cheaper because here you're paying $42, but over here you're paying only 34. So clearly the equal point, where it's the same price for both, is some number of miles between 0 and 140. So we come down here, we've got our wonderful picture. And you can see that if you drive no miles, then this guy down here is cheaper because you pay nothing as opposed to paying 20. So apparently being above is bad, right? Because if you're above, you're paying more. And so like, for example, at this mileage right here, which one's above? I'll draw this one here is company B, and this one over here is company A. So I'll ask again, at 30 miles, which one is above? B. B is still more expensive. How about at 70 miles? B is still more expensive, but you can see it's not by as much, right? Like it's catching up, and this is what Ryan had pointed out to us. And then we get past some magical spot, and then we come out to here, and we looked at the 140 mile mark. Which one is more expensive there? Now it's A, and that's the extra that you end up paying. So where's the point where they're equal? It's at 100. What are we looking at to decide where these two things are equal? What are we looking for? Is where they cross each other, the common point. And we're going to call that the point of intersection. So this guy right here is the point of intersection. And let's go ahead and write down the coordinates of that point. Now this is a complete estimate and it hinges on having an accurate graph. But what's the x value at that point? Looks like it's right around 100. And the y value at that point is 30. And that's x, and that's y. And the idea is, if we got this right, then 130 should satisfy both equations that we came up with. So we're going to check that in a moment. Everybody with us so far with finding that intersection point? Any questions? Okay, let's scroll back up to our 2 equations. If we plug in, I'm going to put it here and then I'm going to erase it, but 130. If you plug in 100 for the x right there, do you buy that you get 30 for the y? 0.3 times 100, that's 30. And if you plug in the same 130 over here, plug in 100 for the x, how much is this piece? 10% of 100. It's 10 plus the 20 is the 30. And so, in fact, we have found the magical number of miles we should drive with the same cost. What's the number of miles? It's 100 miles. What does the 30 have to do with the cars? That's the price. If you drive 100 miles, you will pay $30 regardless of which car you use. So in terms of making your decision for company A or B, you just have to ask yourself the simple question, am I expecting to drive more or less than 100 miles? That makes the decision. Questions? Okay, so let's get rid of some of this stuff here, and we'll move on to the next page. Here. Okay, so let's just fill in part H, which just says what is the solution to the system of equations. So it's 130. And then it asks, how can we tell? We just find the point of intersection. Now, doing all that is a lot of work. So if I ask you to solve a system of equations, graphically, it means you got to go through this whole process, draw two lines, do your best to estimate that crossing point, the point of intersection. But there is an easier question that I might ask as well, and that's where I just say determine if something is a solution to a system of equations. In order to determine if that's a solution, we don't need to go through all the process of graphing and finding the point of intersection. All we need to do is plug in. Plug -3, 1 into both equations. We just have to decide if the equations are both true or not. That's all. So if we plug -3 and 1 into the first equation, it goes -3, and then what? -1 equals -4. Right? We're just changing the x and the y to those two numbers. Is it true? It is. So far, so good. That means that the point is on one line, but it doesn't necessarily mean it's also on the other line. So we check. Instead of y, what do we have? 1 equals, maybe, 2x. 2 times what? -3, and then +7. That's -6 plus 7, also right. So is that point a solution? Yes, it's a solution. And that's a far easier question to answer than find the solution, right? What if the point made one equation true, but the other equation false? Is it a solution? No, it's got to make both equations true. Okay, we're going to skip 5. I think I might ask you guys to do that in your groups in a few minutes. Let's move on to the next page. And I will say that that normally, if you just draw two lines, like just go ahead and put your arms up in the air to represent two lines. Everybody put your arms up in the air someplace to represent two lines. So my question to you is two different lines. So as my question to you is, do your two lines meet if they went forever? If your arms extended forever, would your lines meet? So most of you are saying yes. Is there anybody who said no, my lines don't meet? Yeah, like if you had two parallel lines, then they would never meet at all, right? Now, most of the time, if you just draw two random, you can put your arms down. If you look silly, if you draw two random lines, most of the time they're going to intersect at just one point. But occasionally, very rarely, you may end up drawing two lines that don't meet at all, two parallel lines. So I'm going to save some time here. I intended for us to graph both of those equations, both of these, and both of these. But let's save some time on this. I'm going to draw some very inaccurate graphs that capture the idea that we're going to convey here. Most of the time, you have two graphs that intersect at a point. So you can draw those two lines, any old two lines that meet. They're not exactly the two lines I asked for. But this is usually what happens. And you have a solution. It's that point. But sometimes you end up with two lines that are parallel. So draw two lines like that. So if I asked you to find for me all the points that are on both lines, what would you say in the second case? What points are on both lines? None. So when we have a question asking us for a solution, we say there's no solution. There's no way to find a point that's on both lines at the same time. Whereas back in this first case, the solution was a single point, just the intersection. And then it turns out there's actually one other case. There's the intersecting case, which is most of the time. Then there are these two parallel lines which never meet. And it seems like that's every possibility. Either lines hit each other or they don't. But there is one other possibility. It's kind of sneaky, and it's actually hard to draw. But suppose that the first line you drew was this one. And then suppose that you were going to plot the other. You were going to graph the other line. And one point that was on the other line is there, and one point is over there, and you're going to connect the dots to draw the second line. What fluky thing just happened? It's exactly the same line. It could be that the two different lines are really the same line, just in disguise, and that's exactly what's happened here. So I'm going to draw this one as if it's like right next to it, because I can't draw it perfectly on top because you won't see the other one. But occasionally you have these two lines that are exactly the same, even though it's not obvious looking at the equations. So let me ask you this. How many points are on both lines? A lot of them. In fact, any point that's on one is automatically on the other because they're the same. So we would say the solution here has infinitely many points. Infinitely, is that right? Infinitely many solutions. So that's every possibility. Most of the time, two lines will just hit each other in one point. Everything's great. Occasionally, you have these two parallel lines, never meet each other at all, no solutions. Also, occasionally, those two lines might actually be the same line in disguise, infinitely many solutions, because there are infinitely many points on both lines. And then there's vocabulary you can memorize a little bit if you want to. We say that the first set of equations is consistent. They make sense together. The second set of equations is inconsistent. There's no way to find a point that's on both. And then the third one, dependent, just because the one line depends on the other because they're both exactly the same. Not super important vocabulary, but just in case you see it in the book, I want you to have seen it here too. Okay, so I think that that's good. All right, so we've done a lot of skipping around and stuff. I would like us to jump to page 67. And in your groups, you're going to work on this book and CD problem, which actually should look familiar, but we're going to do it slightly differently now from when we did it a few weeks back. So give this a shot. There's another problem on the next page, and if you finish both, we'll go back and ask you to finish some of the ones we skipped here.